breakthrough projects. In this video, we are going to explain about a project titled Forecasting Crude Oil Prices, a deep learning based model. The project introduction centers around machine learning, a subset of artificial intelligence algorithm that enable the system to autonomously acquire knowledge. The project emphasized the significance of deep learning technique, including convolution neural network, deep belief network, and deep recursive neural network. These techniques have demonstrated promising outcomes in various domains such as visual data processing, natural language processing, and speech and audio processing. Within this project, particular attention is of viewing with the deep belief network and their notable performance despite facing the challenges like of lengthy learning times, the requirement of substantial labeled data set for training and the need for selective techniques. The goal of this project is to introduce a novel approach for forecasting the fluctuations in the crude oil prices using the enhanced deep belief network and the long-term short-term memory network models. The project aims to capture the non-linear dynamic of crude oil price changes which are influenced by various market risk factors and creating the increased investment risk. The proposed method is compared against the previous statistical approaches and the result demonstrates that the model based on the proposed method outperforms them in terms of prediction accuracy. These are the basic requirements that are needed to build this project. The first one are hardware requirements that are operating system as Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above. Software requirement Python IDE with version of 3.7. These are the modules that are developed to build this website. The first one is upload the crude oil dataset. In this module, the crude oil dataset is uploaded for further processing. The dataset contains historical crude oil price data, which will be used to train and test the deep learning model for price forecasting. The second module is run deep learning LSTM model and forecast the price. In this module, the deep learning LSTM algorithm is employed to forecast the crude oil price. The LSTM algorithm is known for its ability to capture the long-term dependencies in the time series data. The model is trained using the crude oil dataset and then it is used to predict the future price value based on the learned pattern and features. The LSTM algorithm consists of input, output, and forget layer that filter and process the features from the dataset to make the accurate prediction. And the third module is run deep learning ARMA model and forecast price. In this module, the deep learning ARMA means of auto-regressive moving average algorithm is utilized for crude oil price forecasting. The ARMA algorithm combines the auto-regressive and moving average components to model the time series data. The ARMA model is trained using the crude oil dataset and then it is employed to predict the future price values. However, it is important to note that the accuracy of ARMA model for price prediction may be lower compared to that of LSTM model. And the final module is accuracy graph. This module involves generating an accuracy graph to evaluate the performance of the LSTM and ARMA models for crude oil price forecasting. The accuracy graph provides a visual representation of the accuracy achieved by each model and over a specific time period. By comparing the accuracy of two model insights can be gained regarding the effectiveness in predicting the crude oil prices. The execution of the project. To execute the project, first we need to open the code folder. This is the code folder consisting of different files. The first one is backup folder consisting of the Python files and the dataset folder consisting of the dataset, different values and the dates assigned with it. And the model folder consisting of the .hy file. This .hy file contains the algorithm information which can be loaded into the project code during the runtime to utilize the trainer model for various tasks, such as making the prediction on new data or performing the specific operation. And then crude oil forecast is a Python main file, and the run is a bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. Now click on run.bat file for execution. This is the graphical user interface of the program. First, we need to click on upload the crude oil dataset button. By this, we are importing the dataset from the dataset folder and click on open button. Here we get a screen like of dataset is loaded, and click on run deep learning LSTM model and forecast price button. Here the LSTM will read the dataset and then generate a model. Here for this we need to enter the current oil price in the dialog box to predict the future price. In this screen I entered as the price of 56.15 and click on OK button. Here the prices or predicted prices are given as of like this, and the LSTM gives an accuracy of 99%. And then click on run deep learning ARMA model and forecast price button. To read the dataset and to generate the model, first we need to enter the current price to get the future price. For this, I am entering the current price as of 56.15, and now click on the OK button. By this, we get the predicted prices, and we can see the console for the predicted and expected price and the layers used within it. And here the current price is of this and the predicted price is of like this. Here the ARMA used an accuracy of 70%. And then click on accuracy graph button. Here it gives an bar graph where the x-axis represents of the algorithms we used and the y-axis represents of the value assigned for each algorithm's accuracy. And then close this graph. And this way we can forecast the price of the crude oil. Finally, the project concludes that the proposed method of predicting the crude oil price fluctuations using the improved deep belief network and the long-term short-term memory network model is effective in modeling the non-linear dynamic of crude oil price changes. The results of the experiment show that the proposed method has a superior performance compared to that of the statistical previous works, and it improves the prediction accuracy. We also found that combination of IDBM and LSTM model lowered the mean square error value, and which gives an most accuracy when compared to that of ARMA model.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.